So now let's look at integration by sec substitution. So now if you have an integral of the form, now this is another kind of format. So now if you have 1 over, now this is the root, then we have s squared x squared minus b squared. So if you have an integral of this format, we actually use sec substitution. Now as you can see, is in this case, what happens is we can actually factorize out the b squared. So in factorize out the b squared, we'll have s squared x squared over b squared minus 1. So that's actually what happens. Now therefore, this b, the root of square root of b is actually b squared is b, so I have b into bracket a over b x squared minus 1. So if you have this, anything in this format, we actually use sec substitution. So now where the integral contains a square of a difference of squares written this way. So if it's written in this format, remember the difference between this and sine substitution is inside substitution, it was actually in the reverse. So it was actually the constant subtracting the variable. So now we have the square of the variable subtracting the square of the constant b. So now this is slightly different. So now I have a over b x being equal to sec theta. So anything in that format will require sec substitution. So let's look at an example that requires sec substitution. So now you have the integral of 1 over x into the root of x squared minus 1. So now clearly this requires sec substitution because we have the square of the variable subtracting the constant. So now this will actually clearly require sec substitution. So now in this case, by sec substitution, now this is already arranged properly. By sec substitution, you can already see that this value right here, this x shall be equal to, because we already have this subtracting 1, so we don't need to factorize out anything. So we shall say that x shall be equal to sec theta. So now dx theta shall be equal to sec theta tan theta, because that's the derivative of sec theta. So if we make this subject, dx shall be equal to sec theta tan theta d theta. So now if we solve for theta from here, we can actually see that theta is sec inverse of x. So let's substitute that back into the integral. You can say the integral will now become x into the root of sec squared theta minus 1 times sec theta tan theta d theta. Now we are still left with this other x value right here, which we need to change. But remember that x is actually sec theta. So that means we'll have 1 over sec theta into sec squared theta minus 1 times sec theta tan theta d theta. Now this and this cancel. Then I'll be left with tan theta over this. But remember that sec squared theta minus 1 is actually tan squared theta. So now this is the root of tan squared theta is actually going to be equal to tan theta. So I have the integral of tan theta over tan theta d theta. But remember that this is actually equal to 1. So I'm now finding the integral of 1 d theta, of which I'll have theta plus c. But remember theta is sec inverse of x. So now I'll have sec inverse of x plus c as our answer. Alright, so another question in number 2. So we're being told to evaluate this. So the integral of 1 over x into x squared minus 9, root of x squared minus 9. Now this clearly also requires sec substitution. So what happens is, I can see that the first thing that I need to do is to actually pull out the 9. So I factorize out this 9 so that I'm left with the 1. So I pull out the 9, I'll be having 9 into x squared over 9 minus 1. So the square root of 9 is actually 3. So now when I pull out that 3, the 3 shall actually multiply the x. So I have 3x. And then I will be left with the root into x squared over 9 minus 1. But also remember that 9 is the same as 3 squared. So I can combine the powers with this and I'll have x over 3 squared. And then this is how we'll actually have it looking. So now to have it as this step, we can actually now apply sec substitution. So by sec substitution, this value x over 3 shall be equal to sec theta. So now x will make x a subject, we shall have x being equal to 3 sec theta. So dx d theta, when I differentiate that, it shall be equal to 3 sec theta tan theta. Make dx a subject and dx shall be equal to 3 sec theta tan theta d theta. And then if I'm to solve for theta from right here, I can actually see that theta shall be equal to sec inverse of x over 3. So put everything back into the integral right here, and I'll have 3x into sec squared theta minus 1 times 3 sec theta tan theta d theta. But remember that x was actually represented as 3 sec theta, so that's what I'm going to substitute right there. So I'll have, now because there's already a 3 here, so to be 3 times 3, which is 9, so I'll have 9 sec theta into sec squared theta, root sec squared theta minus 1 times 3 sec theta tan theta d theta. I can also see that this sec theta and this sec theta value shall cancel, and then 9 divided by 3 is 3, so I'll actually have a third outside, and then I have tan theta over this. But remember, sec squared theta minus 1 is also equal to tan squared theta, so the root of that is actually tan theta. So now what I will have is a third into tan theta over the root of tan squared theta, which is actually a third into tan theta over tan theta, which is a third into root of 1 integral of 1 d theta, which is actually theta plus c. But remember, theta is sec inverse of x over 3, so that means I will have a third sec inverse of x over 3 plus c as our answer. Alright, so question number 3, we're being told to evaluate this. Now this actually has limits, so the upper limit is 2 and then the lower limit is 1. So I have 1 over x squared into the root x squared times root of 5x squared minus 1 dx. Now this also requires sec substitution, as I can see from the arrangement. Now what happens is, the first thing I can already see is that I have the 1, I have this subtracting 1, so that means I don't need to factorize out anything, but I can see that I can combine the squares of these two. Now what happens is 5 is the same as root of 5 squared, so that means when I group them, I'll have into bracket root of 5x squared. So now this, when I put this, in case I put this power back in, it will take me back to this original. So this is the best way of actually grouping them and combining their powers. So now what that means is, now I can let root of 5x be equal to sec theta. So now if I make x a subject, x shall be equal to 1 over 5 sec theta. So if I differentiate that, I have dx theta being equal to 1 over root of 5 sec theta tan theta. Make dx subject and dx shall be equal to 1 over root of 5 sec theta tan theta d theta. So if I'm to solve for theta, I can see that theta from actually here, actually I can actually use, let's use this. I can actually say that theta shall be equal to sec inverse of root of 5x. So now, therefore our integral becomes this. So now wherever there is dx, I'm going to put in this, so I'll have this times that. Now how about this x squared here? Now we need to find of actually substituting for it. Now good enough, we actually know what x is, so if x is equal to 1 over root of 5 sec theta, that means x squared shall be equal to that. So x squared shall be equal to 1 over 5 sec squared theta. So substitute that back in, and this is what I have. So substitute this where we have x squared, this is what I have now. Alright, so to get the next answer, all I have to do is get this 1 over root of 5 divided by 1 over 5, and what I'll have is 5 over root of 5, and then inside I'll have, I can see that this and this will reduce, and then I'll be left with sec theta right here. Then I'll have tan theta at the numerator, but sec squared theta minus 1, remember, is tan squared theta, but now the root of tan squared theta is going to be equal to tan theta, so this is why I'm left with that. So now I have 5 into root of 5 into the integral of 1 over sec theta, because tan theta and tan theta cancel. But remember that 1 over sec theta is the same as cos theta. Now the integral of cos theta is sine theta, but remember that in this case we actually have limits. Now we need to find a way of getting this theta in terms of x before we plug in the limits. But remember that root of 5x was equal to sec theta. So what does that mean? It meant that root of 5x is equal to 1 over cos theta. So that means if we make cos theta the subject, cos theta is equal to 1 over root of 5x. So now that we know that, we can actually plug that into a right angled triangle where we have theta as an angle. So that means that because remember that in cos it means adjacent, actually it means adjacent over hypotenuse. Now it means that the hypotenuse is 5x and the adjacent is 1. So we need to first find the opposite, so that we can actually we need to find that opposite value right here, so that we can actually easily find what sine theta represents. So from Pythagoras theorem, 1 squared plus b squared shall be equal to root of 5x squared. Now we need to know what that b is, so b squared is equal to 5x squared minus 1. So b shall be equal to root of 5x squared minus 1. So now we know what the opposite value is. So the opposite is root of 5x squared minus 1. So now to know that, we can actually now know what sine theta represents. Remember that sine theta simply means opposite over hypotenuse. So that means that sine theta shall be equal to root of 5x squared minus 1 over root of 5 times x. So this is what sine theta represents. So we're going to substitute that back in, and this is what we have. So now that we have it this way, we can now plug in the limits. So now we plug in the limits, and we have the difference of the values where we have the upper limit and the values where we have the lower limit. So now when we do that, this is what we end up having. So 20 minus 1 is 19. So that's how we have it like that. And then the numerator, this is what we have on this side. When you multiply this in, and then right here we'll have 5 minus 1 is 4. So multiply this to that, and we also have this. But now root of 5 times root of 5 is actually 5. So 5 times 2 is 10. So that's why we have 10 right there. Root of 5 times root of 5 is 5. So that's why we have it right there. So now next we can find that we can solve this further. Actually, I can already see that this and this reduce. Now 10 divided by 5 is 2. So that's why I'll have a 2 at the denominator. So I have root of 19 over 2 minus. Then this and this reduce, and I'm only left with the root of 4, which is actually 2. So my final answer is root of 19 over 2 minus 2. Alright, so lastly I have an exercise for you. So these are numbers you can try out. So compare your answer to the answer that I actually have on the right hand side of each question. And I believe that after you've tried this out, you'll actually have a better understanding of trigonometric substitution using the secant. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If you did, feel free to tell me below in the comments. I'll make sure to get time to read through your comments and to reply to you. And also, if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Again, my name is Emmanuel Olega. Thank you so much for watching. See you in my next video.